Hello, Algebra 1, and today you're going to be watching this video. I'm going to do a few examples, and then you're going to be doing some practice in your online textbook. We are on page 25 of the student journal. So again, I'll put it's page 25 of the student journal. So here we go. Today we're talking about literal equations, okay? And I know there's no room to write the definition for it here, but we can just write it up here in the margin. Literal equation. You won't really hear this term very much, but you might see it in the textbook. So I want you to be able to recognize that it is simply put as an equation that has two or more variables. Okay, so one really good example would be any type of formula. You guys have used formula before in your life, formulas for like for perimeter, right? Twice the length plus twice the width. Maybe you've done area of a square is length times width. So those are literal equations, okay? Another type of literal equation that you will see in math is going to be a linear literal equation. And those are what you'll see down here in examples 1 through 6. In examples 1 through 6, you're going to see equations that not only have an x, but they also have a y. So this is another form of a literal equation. These literal equations in these problems just happen to also be linear equations. And we have been solving linear equations, meaning we're getting at most one answer for x. What you'll see later in chapter 3 is we're going to be graphing these linear equations, and they will look a lot more like the ones that you see here. Okay, so I want to go through a couple of examples of these just to make sure that you understand how to do your assignment. Now, the goal for these problems in examples 1 through 6 is to solve the literal equation, and they will tell you what variable to solve for. So you can see here that they want you to solve for y. So that means that in this problem, this is the variable that you're trying to isolate. At the end of our problem, it will say y equals da 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 da, right? And let's look at number 1. Number 1, super simple. In number 1, in order to get y by itself, the only thing that we need to move is that minus 2x. Remember, the inverse operation of minus 2x is add 2x. So I'm going to add 2x to both sides. What that does here is it cancels out the negative 2x and the 2x because that is 0. And what I'm left with is I'm left with y equals on the left-hand side. On the right-hand side, you have two terms, and what you will notice about those two terms is one of the terms is 2x, one of them is 15. And they are not like terms. Remember, like terms have to have the same variable. 15 is what we call a constant, so it can't be a like term with something that has a variable. So when I go to write my answer, I always write my x term first, and then I write my constant. You don't necessarily have to, because if you wrote 15 plus 2x, that would mean the same thing. But just for things that we're going to do in the future, it's a lot easier to understand what the problem is telling you if you write your terms on the right-hand side with the variable term first and then the constant. Okay? So what we're doing in these problems is we're taking, again, a problem like number 3, and we are moving things around so that we get y by itself. Remember, it does not matter which side your y term is on at the end of the problem. So to do number 3, I'm going to get y by itself. That's my goal. But before I can get y by itself, I need to get that term with y by itself. So I'm going to move the 8 to the other side. Minus 8, minus 8. It's going to cancel out here. On the left-hand side, what you now see is I have a 5x. I'm just going to bring it down. Okay. And I also have a negative 2 there. Negative 2 is a constant, and it is a like term with negative 8 because negative 8 is also a constant. Remember, constants do not have variables. So I can actually combine those two terms to give me negative 10. And that is going to equal 5y. From here, we need to get y by itself. So what we have to do is we have to divide by 5. So what I'm going to do here is I'm going to divide by 5. And then I'm going to make sure on the other side, I divide the whole entire side by 5. Because when we're adding on both sides or subtracting on both sides, we're doing it to the whole entire side. We are adding 2 to that whole entire side. Now that 2 or whatever you're doing may only be able to combine with certain terms, but it's still being, added to the total value of that entire side. So I have to make sure that when I divide to the entire side. Okay, now I'm going to show you how you simplify this. First of all, 5 over 5 is 1, and 1y is just y. I'm going to do a little bit of side work over here. Okay, so this is sort of either a think bubble, or you can do like just some side work in the margin, right? There it is. Look how cute. So I have this 5x minus 10 all over 5. Note that 5x and the minus 10 are both being divided by 5. So really what's happening here is you have a 5x divided by 5, and you have a negative 10 that's being divided by 5. So by splitting it up into two separate fractions that have a common denominator, it is equivalent to this expression. So by doing that, it makes it a lot easier to simplify. I can see that 5 over 5 is going to give me 1, which just gives me x, and negative 10 over 5 just gives me the minus 2. So on that left-hand side, I'm going to have x minus 2. If you chose to put the y on the left-hand side, you're going to get the same answer, except the whole entire thing is going to be flipped around. So maybe you wrote it as 1 equals x minus 2. That means the same exact thing as this. Okay? So it doesn't matter which side the y is on, as long as both of the sides that you have are the same sides that I have. Okay. So and again, if you did this problem and you only simplified this 5 in front of the x with the denominator of 5, that would give you x minus 10. Do that. This is not correct. The answer is x minus 2 because both of these terms need to be divided by 5. I would like you to try a couple more problems on your own. So if you want to pause this video and try out numbers 5 and 6, I will write the work and the answers so that you can check it before you move on to your practice. Okay, so here you can see the work on numbers 5 and 6 if you tried these ones on your own. On number 5, I subtracted 3x on both sides, and then I divided negative 1 to everything on both sides. Remember that negative 1 needs to be divided to both terms on the right-hand side. So you can see that side work over here of how I got to my final answer of y equals 3x plus 4. On number 6, I subtracted 7 on both sides, making sure to only combine it with the other constants on the left-hand side. That gave me 3x minus 6 equals negative 4y. I divided both sides by negative 4, and on this one, I didn't show the side work, but it would be 3x divided by negative 4, and it would be minus 6 divided by negative 4. So the negative 3/4, it just stays as negative 3/4. It doesn't reduce. Number negative 6 over negative 4, the negative over negative is a positive, and both of these can be reduced by a 2. Please do not use mixed numbers or decimals within your equations. We would like reduced improper fractions only. There is nothing improper about an improper fraction. It is simply just a number. Also, when it comes to a negative on a fraction can go in the numerator, it can go in the denominator, and it can also go in the middle. When dealing with a fraction and a variable, the variable can go in the numerator, but what you will often see is that they write the variable off to the side of the fraction, sort of in the middle. So I hope this video helps. Go to your Schoology page or go to Big Ideas and see your assignment. Don't forget to upload your work with your assignment, and best of luck on your practice.